The light that we feel around us on our faces, can it create a black hole? Can a black hole be created purely from electromagnetic photons? In 1955, the famous physicist John Wheeler published a paper on mysterious objects called Kugelblitz. These objects form in the universe when pure energy and light create a singularity, after which the light and energy inside it cannot escape, and it can even pull in things from the outside. In simple words, this was a black hole made of light and energy, which could potentially help us travel at 70% of the speed of light in the future. This is based on Einstein's general theory of relativity equation. E is equal to mc squared, where mass and energy are equal. But can such black holes made of light exist in the universe? And if so, how are they formed, and how can we identify them? So, hello guys, you are watching Brain Bargain, and let's get started with another new episode. John Wheeler was one of the most influential physicists of the 20th century, someone who even Stephen Hawking considered an inspiration. Wheeler was the first physicist to give the famous name black hole to the monstrous entities in the universe that were predicted by Einstein's general theory of relativity in 1967, objects that could trap even light with their gravity. Additionally, Wheeler was among the first physicists to introduce the world to several mathematically possible objects from Einstein's theory of relativity, such as quantum fluctuations and wormholes, and to discuss their possible existence in the universe. Remember, Wheeler was making these predictions at a time when no one even knew for sure whether black holes existed. However, in 1955, John Wheeler made one of the most controversial predictions of his career, based on the equations of Einstein's theory of relativity. In the journal Physical Reviews, he predicted a mysterious object called a geon, an object in the universe whose gravity was similar to that of a black hole, meaning it wouldn't allow light to escape from within it. The difference, though, was that this object wasn't formed from the massive cores of dying stars like today's black holes, but was made purely of energy. Technically speaking, only light and radiation energy. This object was referred to as a Kugelblitz. In Einstein's theory of special relativity, there is a very famous equation, E is equal to mc squared, which you must have studied in your schools and colleges. This equation simply states that, according to the laws of physics in our universe, mass and energy are equivalent, meaning conceptually, we can replace any massive object with an equivalent amount of energy and still get the same amount of gravity, or the curvature of space-time, from that energy as we would from the massive object. John Wheeler used this very theory of Einstein to explain the existence of Kugelblitzes. According to Wheeler, a Kugelblitz is a curvature formed in space-time when energy, such as heat, light, and radiation, gets trapped in a very small space-time region, creating its own event horizon. Once something crosses this event horizon, no object coming from outside can return, and the energy within this event horizon also cannot escape once it crosses it. Usually, Kugelblitzes are also known as balls of lightning, and since they are formed purely from light, that is, electromagnetic radiation, we can simply say that these lightning black holes are the creation of light particles, photons, that are considered massless. Also, according to scientists, Kugelblitzes are so extremely hot that they break our current understanding of physics. For example, according to several calculations, they can reach the Planck temperature, which is 1.416808 into 10 to the power 32 Kelvin, or in simple terms, about 1.42 into 10 to the power 32 Kelvin. This means they can be trillions of times hotter than our sun and the hottest objects since the Big Bang itself. But as mysterious and interesting as Kugelblitzes are, reading about them brings up a question. Can black holes formed from light like these actually exist in the universe? Despite Einstein's general theory of relativity in 1916 and the singularity solution later provided by physicist Karl Schwarzschild, throughout the entire 20th century, no one truly believed that mysterious and unrealistic objects like black holes could actually exist in the universe. After all, which physicist, who adheres to the laws of physics and mathematics, would believe that there could be a region in the universe where all the laws of physics break down and an actual singularity exists? But after the year 2000, we began to obtain observational data confirming their existence in the universe. And finally, on April 10, 2019, we even captured a real image of the supermassive black hole M87, located 53.5 million light-years away from Earth. This confirmed the prediction made by Einstein about the concept of singularities nearly 100 years ago. So, does this mean that the black hole of light predicted by Wheeler in the 1960s, also known as the Kugelblitz, could exist in the universe? Well, the answer isn't that simple. As we know, most black holes are formed when a star, about 25 times more massive than our Sun, runs out of fuel after fusion and, due to gravity, collapses with its tremendous matter into a region of space-time, converting into a black hole. But we've also learned that mathematically, based on Einstein's equations, we can replace all the matter in a black hole with energy, and the black hole's gravity and other qualities will remain the same, right? By the 20th century, most scientists believed this, but recently, on May 3, 2024, a paper titled "No Black Holes from Light: A Study on Kugelblitzes" was published. The paper argued that it is absolutely impossible to create a heavily dense object like a black hole purely from radiation and light energy. The scientific reason behind this is related to quantum mechanics. So the concept of a Kugelblitz was proposed at a time when we knew almost nothing about black holes. That's why we had no answers about how quantum mechanics would affect objects like black holes and Kugelblitzes. But in the 1970s, when evidence of the existence of black holes began to emerge, many scientists started calculating and theorizing the effects of quantum mechanics on objects like black holes. Among these scientists was Sir Stephen Hawking, who in 1974 proposed a revolutionary theory known as Hawking radiation. This theory suggested that black holes leak the information and matter they pull in the form of particles and antiparticles into the surrounding spacetime. And since Kugelblitzes and black holes hold similar qualities, many scientists have suggested over time that if Kugelblitzes really exist in the universe, we could potentially use them as power sources for future interplanetary and even interstellar spaceships, enabling our future spacecraft to travel at nearly 70% of the speed of light. Now, this sounds amazing, right? But recent studies suggest that if energy and light were to replace matter at the level of a black hole in spacetime, various quantum mechanical phenomena would start to occur. Among these, the most effective and powerful phenomenon is the Schwinger effect, where electrons and positrons begin to appear out of the emptiness of the universe, a phenomenon observed around the spacetime of stars carrying the most powerful magnetic fields in the universe. And as you might have guessed, we're talking about neutron stars, which hold the second most powerful gravity and the most powerful magnetic fields in the universe, also known as magnetars. According to physicists' findings, when these neutron stars, which hold magnetic fields thousands of times more powerful than Earth's, rotate at 1,000 RPM in their spacetime, electrons and positrons spontaneously appear in the emptiness of space around them. This phenomenon is quite similar to quantum fluctuations in empty space, with the key difference being that while quantum fluctuations produce matter and antimatter that eventually annihilate and disappear back into nothingness, the particles created in the Schwinger effect actually form around the energy leaking from these highly energetic objects due to their insanely powerful electromagnetic fields. This creation process results in the actual loss of the object's energy. And this quantum effect of the Schwinger effect is the reason why the existence of highly energetic objects like Kugelblitzes is improbable. Because if an object with the energy level of a Kugelblitz were placed in a spacetime region as low in density as that of a black hole, it would generate a magnetic field thousands, or maybe even millions of times more powerful than that of a neutron star. At that point, this effect would become so extreme that the spacetime around it would lose energy at a rate of 129 petawatts per second, which is equivalent to thousands of Hiroshima bombs, due to the Schwinger effect. This energy loss would be so significant that the energy levels in that region would not be able to reach the threshold limit necessary to form its own event horizon. In simple terms, according to this research and our current understanding, with the physics and quantum laws of the present universe, an event horizon can only form in one way, when a massive star made of matter collapses. And even though mathematically mass and energy are equal, space-time does not treat them equally. Quantum mechanics also applies different rules to both. These rules can bring black holes made of matter into existence, but it is absolutely impossible to form black holes purely from energy while following quantum rules. So, the existence of Kugelblitzes in the universe is not possible. However, as I mentioned in the introduction, they might have existed at one point in time, 13.8 billion years ago in the early universe. So according to some scientists' theories, while the present universe doesn't allow singularities made purely of energy like Kugelblitzes to exist, it is possible that in the very first fractions of a second after the Big Bang, when the universe was filled not with matter but with pure energy. The density of this energy could have been so high that it might have gathered at some points in spacetime to form its own event horizon, creating Kugelblitz black holes made of energy. This suggests that the supermassive black holes we see at the center of every galaxy in the universe today could be the same early Kugelblitzes of the early universe. But because Kugelblitzes made of energy and normal black holes made of matter share the same physical appearance and qualities, we cannot prove whether these supermassive black holes were really formed from Kugelblitzes or from the collapse of early massive stars. Well, what do you think about this? Be sure to let me know in the comment box below. I hope you learned something new from this video. If you did, please like and share it with your friends.